How do learning rate, epochs, and batch size affect LLM fine-tuning? Imagine trying to teach a robot to understand new words. You want it to learn quickly but not so fast that it forgets what it already knows. That's where fine-tuning large language models comes in. These models are like giant brains that have already learned a lot from reading tons of text. Now, you want to teach them something new or make them better at a specific task. To do that, you need to set some important controls called hyperparameters. The three main ones are learning rate, epochs, and batch size. Each one plays a big role in how well the model learns and how fast it gets there. Let's start with the learning rate. Think of it like the step size the model takes when adjusting its understanding based on new data. If the step is too big, the model might jump past the best answer and become unstable. That can make training messy or cause the model to never settle on the right answer. If the step is too small, it will take a long time to learn, but it will be more precise. When fine-tuning, you usually want a smaller learning rate because the model already knows a lot. If you increase the batch size, which is how many examples the model looks at before updating, you can often raise the learning rate without causing problems. This balance helps the model learn faster and more smoothly. Next, let's talk about epochs. An epoch is like giving the model a full review of the training data. The more epochs you run, the more chances the model has to learn. But if you run too many, it might memorize the data instead of learning general patterns. That's called overfitting, and it makes the model perform poorly on new and seen data. Too few epochs mean the model might not learn enough, which is called underfitting. The key is to watch how the model performs on validation data and stop at just the right time. Now, batch size is about how many examples the model looks at before it updates its understanding. Smaller batches mean the model updates more often, but each update is noisier. This can help the model generalize better but makes training slower. Larger batches give more stable updates because they average over more data. They can speed up training and improve accuracy, but they need more memory and processing power. When fine-tuning, choosing the right batch size depends on your hardware and the kind of data you're working with. Sometimes starting small and gradually increasing the batch size works well. In practice, these three settings are connected. If you increase the batch size, you can often raise the learning rate without causing instability. Monitoring how the model performs during training helps decide when to stop or adjust these parameters. Using too high a learning rate or too few epochs can make the model perform poorly, while too low a learning rate or too many epochs wastes resources or causes overfitting. To sum it up, the learning rate controls how big each step is. Epochs decide how many times the model sees the data, and batch size affects how much data the model processes at once. Adjusting these carefully makes the difference between a model that learns well and one that doesn't. Fine-tuning is all about finding the right mix so the model adapts quickly and accurately to new tasks, all within the fast-changing world of artificial intelligence.